Well, good evening, everyone. I'm Matthew. I'm the observatory manager here at the South Carolina State Museum. It's great to see that we have some folks viewing right now. I am available here to answer any questions that you might have. So feel free to pop any questions you have in the Facebook or YouTube comments. I'll be watching those throughout the stream until we get to the end at 9:30. So I can answer any questions that come up. Right now, the telescope is looking at Saturn. So that's a live view of Saturn that we have there on screen. I'll just tell you that we've been having a little bit of fun with the camera that we use to show planets. And last week, I got some really great video of Jupiter and Saturn, which I might show you all a little later on. But then the camera started showing everything in purple. So that was kind of funny. Everything in purple. So I had to change a bunch of settings, and now it seems like the camera is showing things that are relatively natural color, but we'll see how things go. This is part of the fun of doing astronomy, is sometimes your equipment doesn't work the way you expected it to. So at any rate, if you have any questions, feel free to pop those in the chat. I see some folks. Gina says, watching from Merle Inlet, welcome. So it's great to see you all here. There's Jessica. Hi from Minnesota. Hey, Jessica. Hope things are going well for you up there. Good to see you on Facebook land. And once again, if you have any questions, feel free to pop those in the chat and we'll get those answered for you. So I'm going to ask everybody a question here just to kind of get things moving. So what are Saturn's rings made out of? Does anyone know what Saturn's rings are made out of? Feel free to put those in the chat. All right, Danny says ice. Yeah, right. Any other ideas as to what Saturn's rings are made out of? So we have ice. Yep, another ice. Any other thoughts? I was right. Rocks. All right. So ice and rocks. Very cool. Any other ideas out there in internet land? All right. Well, it looks like we've got some responses for ice and some responses for rocks and gases. So Saturn's rings are made up largely of basically chunks of ice and rock ranging in size from really like little pebbles up to the size of a school bus or so. And they're all going around Saturn in a big racetrack kind of pattern. So, yep, ice and rocks. That's a really good description for what Saturn's rings are made of. Now, do you notice how Saturn is kind of moving around in the image? It's not sitting still, but it looks like it's kind of moving. Does anyone know why? Why does it look like Saturn is kind of moving and dancing around? Oh, we've got a great question here. So while we're thinking about why Saturn looks like it's moving around, Alex asked, how did the rings form? So the rings of Saturn probably formed when stuff like moons of Saturn got too close. And what we call tidal forces um, actually pulled those moons apart. So gravitational forces basically ripped up a bunch of moons and such and formed those rings around the planet. I see we have one thought, I think atmosphere. I think that's why Saturn appears to be kind of jiggling around, and that's absolutely right. So that jiggling motion you're seeing is actually the motion of our atmosphere and air currents in our atmosphere making Saturn appear to move around. This is the same thing that causes stars to twinkle. So especially if you go out on a really cold winter night and you notice that the stars are twinkling, that's actually air currents in our atmosphere causing those twinkling things to happen, that twinkling appearance to happen, I should say. I see Kelly saying the rings are orbiting. Yes, basically what's happening is all those chunks of ice and rock that form the rings are orbiting around Saturn in a giant racetrack. And they're actually held together um, in part by some moons that actually orbit with the rings and keep the ring particles in place. And these are what are called shepherd moons. So it's really kind of a dynamic system. So does anyone know about any of the moons of Saturn? Does anyone know the names of any of the moons of Saturn? If you do, feel free to pop that in the chat. We'll see, because the moons of Saturn are actually absolutely fascinating. And there are astronomers that's what they study. They don't study the planets, they actually study the moons around the planets. Yeah, I see Alex says Titan. Yep, Titan is definitely a moon of Saturn. Titan actually has an atmosphere yeah, Titan looks like the Earth with the rivers and lakes. Yeah, Titan actually has an atmosphere that's kind of like the early Earth. And it actually rains liquid methane on Titan. So how about that? Kind of crazy. Does anyone know any of the other moons of Saturn? I see. Wow, I love it. Yep. Wow, for sure. Saturn is always just such an inspiring planet to look at. Yep, there's a moon called Mimas or Mimas that orbits Saturn, and yeah, it looks like the Death Star. It has a giant crater on it, which makes it look totally like our own Death Star here in the solar system. So I'm going to tell you about a moon of Saturn that I think is really kind of cool. Have you all ever heard of the moon Enceladus? If you have, pop like a yes in the chat. Anyone ever heard of Enceladus? All right, I see a yes. If you haven't heard of Enceladus, feel free to put no in the chat. Jupiter and Saturn have lots of moons. Yep, all right. Nope. Cool. It's absolutely fine if you're not. I've never heard of that moon before. So Enceladus is a really cool moon of Saturn because it has probably a liquid water ocean under its crust, and it has geysers. So Enceladus have geysers. Yeah, so why did Jupiter and Saturn have so many moons? A big reason for that is because Jupiter and Saturn are the largest planets in the solar system, and right, Danny, they have extremely strong gravity. So Jupiter and Saturn tend to capture things. So sometimes they'll do things that they'll capture asteroids that happen to stray too close. And well, Jupiter or Saturn will say, you know what? You're no longer an asteroid. You're now one of my moons, and you got captured. So yeah, that's actually really common. That's actually why the Jupiter and Saturn have so many moons. One of the things you might be noticing is how the image kind of looks like it's changing color. So right now it looks a little bit greenish, and I've been noticing it's been kind of getting bright and dark and bright and dark. Now, I told you earlier that we were having a few little goofy things going on with our camera, and I had it last week literally showing me images of Jupiter and Saturn in purple, like Smurf Saturn. I'm not sure why the camera was doing that. I changed a bunch of settings to make it stop that, but I still think the color's a little bit weird, so we're still researching why that's happening. Um, but the other thing is tonight we do have some clouds. And as the clouds are moving in front of Jupiter and Saturn, or they can actually kind of change the brightness and the color that we're seeing. So as Saturn appears to vary in brightness, I think that's probably actually clouds moving in front of Saturn. If it gets like super, super cloudy tonight and we can't see anything, I actually have some video of Jupiter and Saturn that I can show you. Yeah, look at that. Look at how Saturn's fading out. What kind of scope are you using to image Saturn? So we're using a refracting telescope, which is a telescope that uses lenses to form the image. It's a relatively small telescope. If you've ever been here, you remember that we have that big long telescope. That's our Alvin Clark refractor. And then we have a couple of smaller telescopes. One's a solar telescope, and the other is the telescope we're actually using right now. And it's a little 4-inch refracting telescope, which is actually really great for getting these live streams of planets. So Anita asked, what is the cause of a satellite becoming a moon? So moons are actually natural satellites. That's one really great way to think of them. Um, so moons are natural satellites. So basically, anything that orbits a planet is in some ways a satellite of that planet. Of course, like here on Earth, we have man-made satellites like the International Space Station and Hubble Space Telescope and a whole bunch of other satellites that are up in Earth orbit, weather satellites and all of that. And then, of course, we have the moon, which is a natural satellite. Yeah, I'm noticing how Saturn has really faded out. I'm going to see if I can change any of our camera settings to make Saturn show up a little better here. Let's see if I can bring up my software here. Yep, you might see my mouse pointer, and I think it looks really big. Like super big on screen for you all. I'm trying to change the camera exposure. The other thing that actually could be is the dome has gotten in the way. Let me try going and rotating the dome. And also, I'll be right back. I'm going to go rotate the dome and see if that doesn't make Saturn come back. So here we go. Well, that brought Saturn back a little bit, but I tell you what, there is a big cloud bank that showed up right around Saturn. It's also fairly close to Jupiter, too. So the clouds are kind of messing with us right now. How big is the dome? The dome is about 26 feet in diameter. So since we are having this lovely, lovely cloud problem, I actually am going to show you something different here. And this is actually not something I'd planned to show you tonight. Let's see if I can get I'm going to turn off my screen share here. Let me see if I can get my other picture up. So today, earlier, we were looking at the sun. Oops. My computer is being just a little bit goofy, as computers sometimes like to be. Let's see if I can grab my control window. Okay, almost. There we go. So I'm going to exit this program that's running our camera, and I'm going to bring up something totally different just for a moment here, just because it's awesome. So let me get screen share going again for you here. All right. It's a little bit of a diversion from what we advertised. We'll take a look at Jupiter in just a minute. But does anyone have any idea as to what this is right here? This is actually not live. This is a video that we took today, actually. So we took this during the day when we were open for folks to come in the observatory and actually see the telescope in person. Does anyone know what this is? Okay, I see a vote for sun. Yeah, all right. So definitely see some votes for the sun. And this is indeed the sun. So, what do you see in this image that's really kind of cool? Especially there to the upper right. What is that? Yeah, right. I see Danny says prominences. So the sun is white, and actually the reason why the sun looks white is because we're using a black and white camera. So we use a filtered telescope that kicks out a lot of the light from the sun, but then we have a black and white camera which allows us to see more detail. So I see we have some thoughts that these could be prominences, could be a solar flare. So these are actually prominences. They're actually pretty big prominences, though. Prominences are giant gas eruptions that extend off the surface of the sun. And just looking at these prominences, I think the ones we had today were probably, that big one is probably like 50,000 miles long. So super, super huge. So I'm going to change our view of the sun because I got another video today. So let me just shift that over. Let's see if I can get my window to work here. Again, you're probably seeing my mouse super big. Let's close this video out and we're going to bring this video up. There we go. And now let's go back and have a look at where you all are. All right, so now we have another view of the sun. This is from today as well. And we have the camera set in a different way. So what do you see in this picture of the sun that's really kind of cool? Can you see any black dots anywhere? Yeah, a couple of small sunspots. That's right. So they're like 3 sunspots that form a group. Yeah, those sunspots don't look terribly large, and especially if you're watching on your phone, you're not going to see them really big. Those sunspots are actually about the size of the Earth. So they look really, really small, but they're actually about the size of the Earth. All right, so what I want to do now is, this is a Jupiter and Saturn live stream. So I'm going to bring up Jupiter. I'm actually going to bring up a video of Jupiter that I took last Saturday. So last Saturday, it was beautifully clear. And this Saturday, it's not so great. So I'm going to bring up my video of Jupiter that I took last Saturday, and then I'm going to step off camera, and I'm going to go and look at the cloud situation and see what we've got. And I'm going to try to get a live view of Jupiter. But while we're figuring that out, I'm going to put a picture of Jupiter that we took, actually a video of Jupiter that we took last week. That's actually one of the things we're going to really try to do with these programs is not cancel for weather. And instead, we're going to actually take archived images and use them so that you can actually see cool stuff from our telescope, even on nights when it's cloudy and raining. So there's Jupiter right there. I'm going to go ahead now and see how the situation looks with the clouds and see if we can get a live view of Jupiter. So I'm going to go off camera here. So give me just a sec and let's go see what Jupiter's looking like here. So that's right. Yeah, that's exactly right. The like 4 Galilean moons of Jupiter. Now, we actually don't have the camera set where we can really see those right now. Right now, in this particular video, I set the camera so that we can see those cloud bands on Jupiter. So those stripes that you're seeing, those are cloud bands right there. So I don't have it set for the moons. We can try to see if we can get a look at the moons tonight. So let me just turn off the camera here, and then I'm going to see about pointing the telescope at Jupiter and see if we can work around those clouds that are there. So see you all in just a minute. All right. So if you're just joining us or you've been waiting for a little while, I now have our telescope pointed at Jupiter. So what you're seeing right now is a live view of Jupiter. And you might have also seen us, you probably saw the video of Jupiter go away if you were watching, and then the actual planet, the live view coming in as I was adjusting the telescope and then the camera exposures. So we have a really amazing view of Jupiter here tonight. I really think this looks super cool. So tell me what you think you're seeing here. So we're looking at Jupiter and we see some sort of like stripy looking detail. Does anyone know what that is? So like that big dark stripe that's kind of going right down the middle. And once again, if you have any questions, feel free to pop those questions in the Facebook chat or the YouTube chat, depending on where you're watching. And we'll get them answered. Yeah, Danny says atmospheric bands. And that's exactly what those are. Is we're seeing some of the cloud bands of Jupiter. And tonight actually is a really good view. I was actually surprised at how well those cloud bands are coming through. So there's that big one that's going across kind of just a little bit to the bottom of center. But then you might be able to see, especially if you're looking on a computer screen, probably is a little harder on a phone. Is actually another band that's up a little bit. It's much, much thinner and much, much fainter. But definitely we're seeing some of the cloud bands of Jupiter right there. So again, you'll see how the planet gets a little bit brighter and then darker and then brighter and darker. And that's probably, again, because we've got some clouds in the way. In fact, it looks like the clouds might have moved a little bit, and now we're almost seeing too much of Jupiter. So this might be a time to see if I can get us a view of the moons. So let me bring my camera control software up and just really turn the exposure on the camera up. See if we can see any moons here. It's going to take me just a second to get everything adjusted. Let's turn up the gain as well. Okay. A little more. Controls on this camera are really touchy. There we go. So we've turned up the camera quite a bit, and now we really can't see that detail on Jupiter, but we can see 3 of Jupiter's largest moons to the right. So they're all kind of in a row. So 2 are close together, fairly close to the planet, and they're fairly bright. And then 1 is sort of off towards the edge. So definitely we're looking at 3 of the moons of Jupiter there. I used to have an app on my phone that actually identified which moon was which. Do I still have that app? I do. Let's see here. All right, so the moon that's closest to Jupiter is Io. The moon that's right next to Io is Europa. And then the one kind of off to the side there is Callisto. And I think I might see Ganymede sort of. There's a 4th one kind of popping in. So I think I might see Ganymede too. So yeah, definitely getting the moons there. So my favorite moon of Jupiter is Europa, because Europa, again, has a subsurface ocean. And whenever you see oceans like that, you might think, there could be life there. So once again, if you have any questions about our view here, feel free to pop those in the Facebook or YouTube comments, and we'll get those answered. So I'm just going to hang out here for a minute and see if any questions pop up. And then after a few minutes, we'll go back and have a look at the actual image of the planet. So any questions? Yeah, so is there a fourth moon on the screen? I believe that's what we're seeing. All four moons of Jupiter are kind of lined up in a row tonight, off to the right. So yep, I think that's what we've got right there. Now, Jupiter actually has 79 moons. So I see that Anita asked, how many moons? Yep, Jupiter has has 79 moons. Now, a lot of them are super, super small, and we need a really big telescope to see them, including telescopes like the Hubble Space Telescope. Really, with a smaller telescope like the one we have here at the museum, we can only see these four largest and brightest moons. But yeah, again, Jupiter and Saturn have lots of moons because these are big planets with a lot of gravity, and then they tend to just capture things that come by, like asteroids and such, and turn them into moons. So I'll hang out. Yeah, 79 moon could be even more. So what tends to happen is we tend to find more and more of these moons. So really with both Jupiter and Saturn, scientists keep discovering more moons. And usually when a new moon is discovered, it's some little tiny thing. And like in the case of Saturn, it's like, is it really a moon or is it actually a part of the rings? So that's kind of the debate that we get. So once again, any questions, feel free just to pop those in the chat and I'll answer them on camera. And I'm going to go ahead now and switch us back to the actual planet view. So we're going to go back to seeing not the moons of Jupiter, but the actual planet. So I'm going to go to my camera control software and change the exposure back and get our view of the planet back. So what you're seeing is me changing the exposure setting on the camera to try to get the best view. So it's like, that's a little too low, that's a little too high. I want to turn it down just a bit, and it's a really touchy control. That actually looks pretty good. Let's see if I change the gain. Yeah, let's turn the gain up. Yeah, these astronomy cameras are actually, they've got lots of controls on them. It's kind of different from taking a picture with, say, your phone camera. All right, so now for the last about 20 minutes or so of our stream, we're just going to enjoy this live view of Jupiter. And if you have any questions, feel free to just pop them in the chat. Distance from Earth. Great question. So on average, Jupiter is somewhere around 500 million miles from Earth, usually probably a little less than that, but several hundred million miles. And Saturn is a little under 1 billion miles from Earth. I love it. Barbara says, cool. Danny asks, are there any more planned Jupiter or Saturn-based probes like Galileo or Cassini-Huygens? So right now, we actually have a probe that's in orbit around Jupiter called Juno. And Juno is sending back data and images actively. And then Cassini was in orbit around Saturn. So you mentioned Cassini. We actually crashed Cassini into Saturn. So to eliminate any possibility of Earth-based or microbes that Cassini might have brought with it from Earth, from contaminating any of Saturn's moons. So yes, there are some future missions that they're still kind of on the drawing board, and haven't really been approved yet. And one of the big ones is to actually send a probe to Jupiter's moon Europa, which is the moon that has that subsurface ocean under an icy core, or an icy crust rather. So the idea is to drill down into that ocean and get a sample of it and see if there could be life in that ocean. So yeah, I think that mission is still probably a decade or more off, but that's definitely one of the future missions to Jupiter that gets talked about a lot. Yeah, it would really be cool if it could send another probe to Uranus. Absolutely. Uranus also has I'm trying to remember if it's Uranus or Neptune that has the moon Triton. Triton's another really interesting moon that has ice geysers and ice volcanoes and that kind of cool stuff. Let me look that up really quick. This is one I just make sure I'm not about to say weird things. So, moon Triton. Which planet is Triton? So the largest satellite of the planet Neptune. There we go. That's what I thought. So all of the gas giant planets have rings. So Jupiter, Saturn, Uranus, and Neptune. If you want to get technical, Uranus and Neptune are actually ice giants. And that's a big kind of whole nother discussion. But all four of the giant planets have rings. Jupiter, excuse me, what am I talking about here? Saturn's rings just happen to be the ones that are the most prominent, the brightest, the ones that we can really see the best. The rings of the other planets are really, really faint, and you need a really big telescope or even a spacecraft to see them. That's about right. Yep, Uranus and Neptune are made of methane and ammonia. Jupiter and Saturn are hydrogen and helium. Yep. Yeah, Uranus and Neptune are actually very different planets in some ways from Jupiter and Saturn. We kind of lump them all together as giant planets or gas giant planets, but Uranus and Neptune are actually very different beasts. So once again, if you're just now tuning in, we're looking at a live view of Jupiter from one of the telescopes here at the South Carolina State Museum Observatory in Columbia, South Carolina. Feel free to pop any questions that you might have in the Facebook or YouTube comments, and we'll get those answered for you on camera. So feel free to send me any questions you might have, and we'll answer them. And otherwise, just enjoy the view. We'll be here till about 9:30. Yeah, so Danny says, thank you for hosting this live session. So we're going to be doing these live stream sessions on the first and third Saturdays of the month. So the next one will be Saturday, October the 16th, and it'll be the same time, 8:30 to 9:30. As we get into standard time in November, we're going to move these earlier by an hour. So it'll become 7:30 to 8:30 because the sun will set earlier. So the one on October 16th, we're going to be looking at the moon. October the 16th is International Observe the Moon Night. So it's a night when there are public moon gazing events, if you will, all around the world. So we'll be sharing a virtual view of the moon, weather permitting. Now, if it is cloudy, we will still be here and we'll be showing some archived video and pictures of the moon that we've taken in the past. And with any luck, we'll actually have a view of the moon that we've taken, like a video of the moon that we've taken really recently, like within a few days of the session. So I'll keep an eye on the weather forecast, see how things are looking, and see if we can get some live footage if it looks like the actual Saturday night's going to be cloudy. So again, that's on October 16th. I'll have another one of these, and then we'll continue these really through. The idea is to continue them through really the beginning of March, and then reassess when we go back on daylight saving time and it starts getting dark a lot later. Thanks for joining us, Anita. It's great to see you. Looks like Jupiter's getting a little dimmer there. That's either a cloud or the dome. I'm going to pop in the observatory and see if we need to rotate the dome. Yes, I see a comment there from Toby. Awesome. Yeah, pretty cool view here of Jupiter. Been trying to adjust the camera to get the right exposure after it started looking dim. It looks like I need to adjust it just a little bit more here. Turn it down just a smidge here. Again, very touchy control here. That looks pretty good. So once again, if you just tuned in we're going to be up till about 9:30, and if you have any questions, feel free to pop those in the Facebook or YouTube chat. And we're looking at a live view of Jupiter right here. And you can see those cloud bands, especially that big one down towards the bottom that is crossing the planet. So Anita asked, are there bands all the time? Yep, there are. So these cloud bands are always there. They can change just a little bit, but they're always there. Other thing that we don't see tonight is the red spot. And that's probably because the red spot is on the side of the planet that's facing away from us. Jupiter actually orbits once every, or excuse me, not orbits. Jupiter rotates, there we go, once every 10 hours or so. So it really rotates quite quickly. And there are times when that red spot actually does face us here on the Earth, and then we can actually see it in those cloud bands. All right. Well, thank you all so much. We'll be streaming again on October 16th, 8:30 to 9:30 p.m. International Observe the Moon Night that evening, and we'll be looking at the moon. So tune in on the South Carolina State Museum's Facebook or YouTube pages for that. We'll have a wonderful evening. Bye now.